This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be refactoring our forest system to make it a little bit more extensible and even a little bit more optimized, hopefully. So the main issue we're going to be tackling here is the fact that all of our unit types right now are hard-coded into the system. We see multiple places here that grass, rabbit, and wolf. There's the profiles, the starting values, we have the counts down here, we even have a separate set of variables that we are hiding from the inspector. And so if we wanted to add a new unit type, for example, or remove a unit type, we would have to go through each of these and change that. And that's never really a good sign in your system. So instead what we're going to do is we're going to kind of group these into a collection that Unity can iterate through rather than keeping them separate and manually controlled. So to start, we're going to jump into our forest system and look at our variables. And so like right here, we see our profiles are these three separate variables, and we're going to change any situation where we see this into an array. So in this case here, I'm going to change this from these three to a public unit profile array, and I'll just call that unit profiles. Same for our transforms here. We're going to change this to a transform array and call it unit holders. In our session settings, let's say public int array, starting units. Change this to a public int array called unit count. And finally, our created variables we'll simply call units created. Now the one place that this is going to be a little bit of an issue for us is our starting units. The unit count, unit holders, and units created are all kind of procedurally created when the session starts, so we know that those will reflect the number of units here. However, we want to be able to manually put in the number of starting units for each unit type, and so we need to kind of leave user control over this array. So we can't guarantee that this array will be the same size as the array up here, and so we're going to need to check for that in our start method. So down in start, what we'll do is we're going to say if starting units.length is less than our unit profiles.length. Then what we're going to do, in this case where we don't have enough data, at some point we're going to get to a profile that doesn't have a starting unit count with it, so we should not just continue at this point. We should probably just cancel out and say something like debug.log error, not enough starting unit data, and then simply return. We'll just stop the program right here. Now there's also the possibility that we have more starting units than we do unit profiles, in which case the program will run fine, but we may want to just alert the user that, hey, something's off here, and so you may not be getting the results you expected because you've got some extra values in here. So we'll say else if starting units.length is greater than unit profiles.length. And we'll simply debug log warning. We don't have to stop in this case. We can still run the program. It won't, we're not going to run into an error that's going to crash the program. But we're going to say here more starting units data than expected. And that's just going to let the user know so that if they see something that they're not expecting, this might be the reason why. Now one other thing I'm noticing here is kind of refactoring as I'm refactoring is that I'm calling unit profiles.length a couple times. I'm also calling starting units.length a couple times, but I know this is basically the only place I'm going to care about starting unit.length. However, this one I'm going to call repeatedly as I'm iterating through these different arrays. So what I may want to do is just kind of cache that information somewhere. So I'm going to create a new variable up here in the session data. I'm going to call this a public int called unit type count. And what we'll do is in our start method, before we even start checking for these things, we're simply going to say unit type count equals unit profiles.length. Unit profiles, the variable dot length. And now we can start replacing this anywhere that we have it. So here we can say unit type count, likewise down here. And now anywhere where we need this information, we can simply get that one variable rather than having to call the length property and getting that from the array each time. Saves us a little bit of time, a little bit of processing power. Okay, so with that, now we can start going into our other methods and fixing some of these errors that we now have coming up here. Most of them being that a lot of the holders and profiles and stuff that we had named previously no longer exist. So to start, we're going to go into our setup forest. And in here, right now what we're doing is we're setting up the different unit holders. As well, what we're going to do now is we're actually going to create those arrays for the, or I should say, initialize the arrays for the unit counts and the units created as well. So instead of doing each of these individually, we're going to set up a new array for our unit holders. So we're going to say unit holders equals a new transform array, and the size of that is going to be that unit type count. Same will go for the unit count. That'll be unit count equals new int array of size unit type count, and our units created will also be a new integer array of unit type count. Now at this point we've created the array to hold our unit holders, but we haven't actually created them yet. We haven't done this process of creating the game objects. So we're going to take this basic idea that we have here and we're going to kind of generalize it. So we'll say for int I equals 0, I is less than unit type count, I++. And in here, we're going to set our unit holders at index I equal to a new game object. And we're going to give this the name of unit profiles I.name. So we're going to get that same index in the unit profiles, get the name off of it. And we're going to make sure that we actually get the transform component off of this new game object. And so that's going to get passed into the array here. We're also going to make this again, like we did here, a child of our current object. So we'll say unit holders I.setParent simply to our transform. So with that, we can delete all of these. From there, we iterate again through our grass, rabbits, and wolves down here, so we can just continue doing that in this loop here and just keep iterating, do these while we're iterating through the unit types. These don't interact with one another at this point, so we don't have to worry about having all three set up right away. We can create the holder, create the grass all at once, and then move on to the rabbits, and then move on to the wolves. So what we'll do here is we're going to add a new loop inside of here. And this one I'm actually going to use j instead of I because we're already using I up here. The length is going to be starting units at index I. And that's why we need to make sure that we have data for each of these, because otherwise at this point we would potentially, if the starting units array was too short, we'd be trying to access something that is outside of the array. We'd throw a runtime exception and the whole system would stop. So here what we'll do is we'll say create unit and pass in unit profiles I, and we're also going to pass in the value of I here, and we'll get to that in a second as to why we're doing that. But for right now, just for sake of argument, it's going to be like we're kind of tracking which iteration we're on, and that'll help us in our create unit method for right now. So we can now get rid of all of these loops that we have here. So inside of our create unit method, we're going to add another parameter, which is going to be integer I, and that again is just going to be kind of a tracker for where we are. And where this really becomes important is going to be when we're initializing our units. So I'm going to also pass that then from there into our initialize method. And obviously right now it's not looking for that extra information, so it's going to kind of yell at us, but just trust that we're going to change that as we go. Run game loop does not have any changes to it. Increment tick, however, is where we're going to do our next kind of big set of changes. So right now what we're doing is we're starting with grass, checking if the grass multiplies, and then checking if it eats, checking if the rabbits multiply, checking if they eat, and then checking if the wolves multiply. So we can, again, here, iterate through all these things rather than doing them individually. So what we'll do is we'll add another for loop. I is less than unit type count. And we'll say in here, check for multiply, unit profiles, I, unit holders, I, and again we're going to pass in that extra I information here as well, because this is another situation where we may eventually be creating more units and we're going to need that tracker information. Then we're going to say, for each transform U in unit holders I, we're going to call U get component unit and call onTick. So now we can eliminate all of these repeated calls, though we do want to make sure that we keep increasing the number of ticks in the session. So that's all there. We just have that red because of the extra data that we have there. So in check for multiply, we now need to add this extra piece, and I'm going to call this int iter for iteration. I can't just use I because we are going to have a loop with I in here, but for now we can just keep it in there as this iter. And down in create unit, we're going to pass iter. So now again, that's why we added that in, was so that we can pass it back to create unit, which is ultimately going to pass that iteration information to the initialize method in our unit, which we'll get to in just a minute. On unit def, we were using a switch statement right now. We're going to be able to eliminate this. We can say, instead of switching between, or switching and seeing which one of these the case is, we can simply say for int I less than unit type count, and then if the profile that we're passing in here of the unit matches the unit profile in our list of, or in our array of profiles, then we can simply change the unit count and decrement that by 1 of that same index. For get unit, likewise, instead of checking individually what each of these are, we can remove this and iterate through again. We'll say for int I is less than unit type count if unit type, the type that we're trying to get, equals unit profiles I dot unit type. So this is the plant or animal we're checking for. You know, does the one we have here, is it a plant or an animal? Unfortunately, this keeps trying to give me the class name and not the array name, but that's okay. Then we also want to check at this point if unit holders I dot child count is greater than 0, then we will return unit holders I dot get child 0 dot get component and return specifically the unit off of that. So, for example, if we're looking for an animal On our first one, we have grass. Grass is not an animal, so we loop to rabbits. We can then check for rabbits. Let's say, unit type is animal for rabbits. However, there aren't any rabbit children. We'll loop back again, check for wolves. If unit type is an animal again, there are some wolves, we will return the wolves. If we get through this entire list and there's nothing matching what the particular unit is looking for, we need to return null, just to say, hey, there was nothing that matches the criteria you were looking for. And so that's all we need to do inside of the forest system itself. Now we do need to, though, update in our unit that initialize method a little bit. Because here again, we see now in unit initialize, we have a lot of kind of repeated content here trying to handle how to initialize these units. So the first thing I want to do is I want to make sure that I add in that integer I for the iteration to determine which iteration we're on. Are we on grass? Are we on rabbit? Are we on wolf? And we're going to basically do all of these things. We're going to set the name. We're going to set the transform. We're going to set the transform as parent, I should say. We're going to increment the appropriate values, but we're going to do it all at once. So we can keep these two lines here, but then from here forward, we're just going to kind of generalize all this. So we'll say base name equals profile.name plus, we'll add a space, plus forest dot units created, and we're looking for specifically the one that matches up, and this is why so if we're looking for grass, we're going to want that to be 0. If we're looking for rabbits, that'd be 1, etc. It just gives us a way to check that without having to check against the name or some other switch case. Then we'll say transform.setParent to forest.unitHolders I. So again, if it's grass, it'll be assigned to the grass holder, etc. Forest.units created I will increment by 1. And same with forest.unitCount, increment by 1. There is one little bit of a change or one sort of kind of switch check that we're going to have to do, which is that if it's a consumer, like a rabbit or a wolf, it's going to need to have that hunger shown. If it's grass or something that doesn't eat, it doesn't. So what we can do here is we can simply say if profile.consumer, then we're going to want to call our setName method, which will add in that hunger information, else the name of this object will simply equal the base name because it doesn't need that extra information added. So with that, we can now get rid of all of our repeated initialization information. And that actually completes the refactoring for being able to now kind of modularize our system or make it a little bit more extensible, and that we could add now a new unit and we would simply be adding it to the array, and as long as we have our starting units matching up, everything else will handle itself. So let's go back to Unity and see this in action. Take probably a moment for this to compile, but now we have, for each of these, we have unit profiles as an array, starting units, as well as unit count, and hidden from there, the units created as well. So first thing I'm going to do, I'm going to quickly lock this so I don't lose focus on it. Go to profiles. I will add our grass to our unit profiles, our rabbit, and our wolf. I can then just make sure that the starting units is the same, whoops, not 30, just 3, same length. Have our 20, 10, and 5. I'll open this up just so we can see what happens with it, and as I hit play here, we should see that our unit count opens up. It's showing us the same information we had before, 20, 10, 5, and I can start jumping through. And we see that everything is populating as it had before, including our holders, which are all getting stored with the appropriate units and are all stored within the forest. and our information is updating as we had it doing before. So no real functionality has changed at this point. We simply have the ability now that we could add another element into here and it would just work by its nature, so long as we make sure that the starting units is added as well. It is worth noting that now the kind of order of how these will activate is based on the order in the array, so that if you were to put wolves before rabbits, say, then wolves would start eating before rabbits had a chance to multiply, which could impact the balance of your system. Now, one other thing I did want to do is there's a little bit of an inoptimal situation that's going on, especially now that we've kind of merged the behaviors of all of these things, which is if we go back to our forest system and into our increment tick here, what happens is first for each unit type, we first check for multiply, which is handled within the forest system, and then we do this on tick action, which is going to happen for basically every single unit of the type that we're on. Now, right now, all that on tick is doing is checking for hunger situations. It's, am I hungry enough to eat? If I am, then I will try to eat something, which means that our grass doesn't really need to do any of this. So it's kind of a waste for us to call this. In fact, we can even see if we go to onTick in our unit class, we see that the first thing we do is we check, are you a consumer? If you're not, then don't even do anything in here. And so we're just making, especially when we get into our really higher levels and we have thousands of grass, we're making thousands of calls to this onTick. That's really just passing control back to the forest system, which is really kind of wasteful. So instead of doing this profile consumer check here, I'm actually going to delete it from the onTick method in unit. I'm going to delete that altogether. I will. So now onTick will happen for anything that does it. But what we'll do is instead of checking for consumer there, we're going to check it here first. We're going to say if unit profiles I dot consumer then and only then do we start iterating through every unit in that particular holder. So for grass, we're skipping that altogether. We're skipping potentially thousands of steps there. Likewise, we can actually do this in our check for multiply, because right here where we're checking for healthy units are again only relevant if the unit is something that eats. So for grass, again, we might be checking thousands of units of grass to see if it's healthy when we already know the answer is true. So what we can do here is we'll again say if profile, in this case, because we're getting the direct profile that we need, profile dot consumer then we will go through this process of checking which units are healthy. However, if it is not a consumer, then we know that all units are healthy, and therefore healthy units should equal the number of units of that type. So we can simply say healthy units equals holder dot child count. So we'll get all of the children in that particular holder, and that's going to be the number of our healthy units. So those are a couple of small changes that we're making just to do a little bit of optimization and just saving us a number of method calls. We'll see again if we hit play in Unity that our functionality is still exactly the same. We still have all our grass, rabbits, wolves. Keeps happening. But we should ideally get a little bit, at least, of optimization out of there. One other optimization thing you can do is that these logs to the console are actually probably going to take up potentially most of the time that you're going to be seeing as things get slower and slower. It, for some reason, is a bit of a slow call for Unity. So you can also get rid of these calls. If we simply double click on this and we can see where that line is, it's in the eat method inside of our unit. We can simply comment that out, and that's another just kind of a quick optimization that you can do that will save you some time as you are jumping through and simulating your system. So that actually brings our systems tutorial to a close. Thank you so much for watching, those who have followed through the entire series. I hope you've gotten some valuable information out of it and it helps you implement systems in your own games. And I'll be back next week with a new video. I might actually be doing something a bit tangentially related to systems, but it's not going to be part of the series proper. But we've got a lot of good content coming up, so as always, thank you so much for watching, and I'll see you next time.